Okay, so what? I said so.
And I said buttons on your underwear. My grandfather just said all the time. Somebody said so.
So I would say hold on, and my grandfather would go holding. It's like, oh my god. And then I would say that, and you'd go, well, he's my God too. Anyway, so we're at day 3 of auth. We have our front end talking to our back end. We have created our infrastructure. We've gotten SQLize up and running. We've played around with Postgres. I've confused everyone on Postgres. I've recorded a video on Postgres. Hopefully that will fix the confusion on Postgres. Now, where are we? Yep. So we got just some test data sending, right? Hello world, and that's pretty much it. So let's identify what else do we need to do. So we had this create account form, but we don't have it working yet, right? No data is going up to the server. We don't have it storing in the database. No data is coming back from the server. We also don't have a login page yet. So those are actually the only 2 things that we're going to do tonight with an asterisk. So the only 2 things we're going to do is get create account working and then get the login working. And then we're going to make it more secure. And we're going to make it more secure. We're going to make it more secure. We're just going to add layers on top of that. But to get started, we need to get our server fired up. So I'm going to open the code that I've been working on the past couple of days. And I'm going to go to my terminal. I'm going to blow it up. So I am in my terminal going to CD to my backend, and I'm going to npm start it, and I'm probably going to, no, I'm not, I'm going to nodemon it.
I was going to ask.
Thank you. Okay, and I'm gonna get an error right off the bat. Why? Because I don't have my Postgres server running. So I'm going to go ahead and open up the Postgres app. Sure, it can update automatically. And all I'm going to do is I'm going to fire it up. I'm going to hit start. I'm going to come back to my backend server, and I'm going to run nodemon. Okay, no errors. Our SQL is executing. Great. Now, if we hand anyone else this code, how do they know to run nodemon? Or how do they know npm start is kind of a standard everywhere, right? So we're going to prevent us from making that mistake again. We're going to tell npm what start means. So we're going to go to our package.json in our backend. Make sure you're in the backend package.json, not the front end one. And in here, we have this thing called scripts. And the only thing we have is a test right now. So if I run npm test, it says no test specified, right? Well, where does it get this error no test specified? It's pulling it right from here. So all npm test is doing is just running whatever this code is. So what we're going to do is we're basically going to map npm start to nodemon. We're going to tell npm how to start. And so what we're going to do in here is just do a comma at the end of that line. Now, this is a raw JSON file, so the keys have to be in quotes too, not like JavaScript where you can leave the keys outside of quotes. So we're going to say start and a colon, and all we're going to do is type in nodemon in quotes. That's in the backend package.json. So now, when we run npm start, it's going to fire up nodemon for us. Now, total optional step, you could continue running nodemon, but so you're starting your React app the same way you're starting your backend, we can just add that to the package.json. Okay, now that we have that running, I'm going to open up a new terminal. I'm going to cd to my front end, and I'm going to npm start there as well. And that should fire up a new browser window for me. Mhm.
npm start.
Yes.
That's what I did.
Make sure to save your package.json. Okay, so important to recap where we left off yesterday. If we look in our console, we have hello showing up. And let's figure out where it's getting hello. So I'm going to go to my front end code, and I'm going to look in my app.jsx. And what I'm seeing here is a component did mount, right? So when the page first loads, go do a fetch to test. And this is going to use the method post. We're letting it know we're sending up some JSON, and we're sending that JSON up, hello world. So let's jump to our backend, and our backend code is in index.js. And in our index.js, we have the models, we have a bunch of things happening, but in our app.post, we are console logging out rec.body.hello. So if we look in our backend terminal, we will see that world printed out there, okay? And then we're sending back world hello, okay? So when we go back to our front end code, we're going to see we're getting some JSON back, but we need to parse it out on the front end. And once it's parsed, we are console logging out data world. Okay? And so when we look in our console, we have hello showing up. So it's very easy to get lost in what console it should be showing up in and what terminal. So when things break, it's important to look in both terminals, the terminal that you're running your React app in, the terminal that you're running your Node Express server in, and then also the console in the browser, because those are all three different places where things could break. Okay, so we have our API happening, our API call happening, data's going back and forth. Now let's make this create account work. So in order to get the values of username, password, and confirm password, we would normally, what would we normally do? How did we do it before? How did we get some data out of the front end? Think back to like the message app. How did we access the data that's in that input field? So we use jQuery, right? And we put an ID on it, and then we use the $ and the £sign and the ID, and then we said .val, and that pulled the value out of it. Well, we aren't using jQuery in this project, although theoretically we could. We need to do it the more React way. So the React way is whenever someone types a letter, we need to put that data into state, right? State is the kind of the variables that are happening at runtime. The data that is in the page is what the state is. So what we're going to do, we're going to pull down here, and we will just work with the username to start. So what we're going to do on the input field is we are going to say value equals, and we're going to say this.state.username. And when we do this, what's going to happen is it's going to say cannot read property username of null. It's like, you didn't tell me what this.state.username is, so I'm confused. So what we're going to do is we're going to go back up to our code, and we are going to say state equals, and we're going to say username is equal to an empty string. And we're going to put that in an object. Okay? So when we come back in here and we refresh, we get our page back. And I can click into my username field and type away, and nothing's going into username. So what's happening here is React is going, I don't care what you type into that now. Username is always coming from state, and state is equal to an empty string in username, so I'm not going to do anything. So what we're going to do is come back to our input, and not only are we going to pass it the value, we are also going to tell it what happens when there is a change. So we're going to say on change, get the event that happens. And that event, let's just console.log it. So we kind of see what happens, make sure this code is firing properly. So we'll go back, we'll go in here, and if I type a letter, you see this synthetic event that pops up. Okay, well, just like vanilla JavaScript, we have access to the target, what we're actually typing in, And we also have access to value. So when I come in here and I type A, you notice A appeared in my console. And if we type in B, B appears in the console. But we still don't have anything showing up in username, right? This had me stuck in React for about 3 days. And I was like, why would anyone want to use React? This is infuriating. And it was because I was either getting the onChange working or I was getting the value working, but I never connected the two together. So what we need to do is we are going to say this.setState. And that's going to set the value of the state to something new. And we are going to say, hey, username is going to be equal to the event.target.value, right? What we had right up here. So I'm going to save that. I'm going to go back to my code. And now when we type, the things are showing up, right? So what's happening is every letter that is typed, we are calling set state again, and we're passing in the new value. And React is going, oh, you changed state, I need to re-render. So it's going to re-render the input field, and it's going to go, what do you want me to render it with? Oh, state is new, you want me to render it with A, B instead of just A. Okay, we're going to see why we're going to do that in a second. So I'm going to quickly just copy this value and onChange, and I'm going to throw that in password and in confirm password. And I'm just going to update the values. And then I also need to do that in addition to making all 3 inputs read from state. I also need to tell it that, hey, at the beginning, password is going to be empty and confirm password is also going to be an empty string. So I'm going to just hop back in here, refresh, make sure that I can type in all 3, which well, isn't that interesting? So let's figure out why it's doing that. I'm going to type in ABC and it filled it in password. That's not what I wanted. So let's look at our code. Okay, we have input type password, ID, value, confirm password, onChange, confirm password. Okay, all of that looks good. So if we scroll up a little bit, our input, when we do an onChange, is getting set into password, but the value is looking at confirm password. So it's going, sure, I'll throw in whatever you type, but what I care about is the value of confirm password. So if we just change that to password, we can type in 1, we can type in 2, and we can type in 3, and it's all working. Sure.
With the on-click, you just pass through like the event thing. You're saying, hey, whatever happens when you click, I want to target that.
Yeah.
Okay, you don't have to pass in a function.
So we actually are passing in a function, and it might not look like it, but this event, this.setState is a function. And why is it a function? Well, we have this arrow over, and we have the curly brace. So whatever code is running in this onChange is actually a function. So to prove it, what I can do is, render is a function here. It's a function in the class, but it's still a function nonetheless. Same with component did mount, right? Both of those are functions. So if we wanted to, we can actually abstract that, and it's not quite a higher order function, but it's along those same lines. So what we can do is say on password change, and that can take a event, and that event is going to do something, right? And what that event is going to do is set state of a password. So I can pull that out, and if I put it up here and save it, then refresh, password goes back to not working, right? Because we haven't linked those two together. So what we can actually do down here is say on change, hey, go look at on password change. And so now we took that function that was just running in the input and kind of hoisted it out up to the class level. And now it's back to working. So it's a function whether we do it kind of inline and have it run right at the on change. And it's also a function if we put it here and then define the function up here. Both of them are valid. When you're doing kind of one-liners and it's just a quick set state, you will commonly see that right in line. But if it is, hey, when I click on this button, I want to do all of these different things like what we're about to do, it's generally considered better form to pull that function out instead of having it in line. Okay, so we have our form working. Does anyone need a pause or need help catching up? Okay. I'm just gonna leave that one input up. That's okay. So the only things you really need to do is add the value and the on change. And then repeat for the other two.
So when I put in note on,
Yep.
or at the end start.
Yep. Okay. So that isn't a problem with what you did. The problem is the server isn't sorting out properly. So let's just scroll up a little bit here, and your issue is error in use. Which means that the server is actually running already somewhere else. So let's just try it again, and it fires right out. Just bring in magnifying glass to class. Okay. We haven't done anything on create account yet. So you're good. Okay, so what's happening there? Let's go to your React code. And what we're doing is we're saying up here, just a bit more, scroll up. We are making a fetch request to the server. And then when it comes back from the server, we're saying, hey, that's probably JSON coming back, so parse it out. But what's happening is the server is sending back JSON, and so you're getting errors. So let's go to index.js. And in here, we have text or test. And let's save that. And hop back to your browser. And refresh. Everyone good? Okay. By the way, this is if you think that I'm going to leave time open at the end of class to kind of go through this and catch up. I will leave at least a half hour at the end of class. So if this is one of those classes where you just want to watch, if you do that, the most important thing is understanding, right? Even if you're not following along with every line, every letter that I type, it's just important to understand why I'm doing it and what the steps are, right? It's not like I'm gonna hide this code from you guys and then go do it on your own, right? It's definitely important to follow along and make sure you can do it, but I will leave time at the end of class to catch up. With that said, if you would like to follow along or even do little parts of it and go, oh, that's interesting, I want to try that, please feel free. Okay, so we have our value pulling from state. We have our on change happening. That's kind of where we were before, right? We had that functionality. Why did we do this on change in the value? Well, now we have access to state when we make our API call happen. So what I'm going to do is on our button, I'm going to do, instead of on change, I'm going to say on click this dot create account. Well, what's create account? It would be nice if it magically worked, but we haven't covered Firebase yet. So we are going to create a new function up here that says create account. And it doesn't take any parameters, but what we're going to do is console log this dot state. And we're going to see what happens, what's in our state. So we're going to refresh here. We're going to type in a password, and we're going to hit create account. And what comes out here is our username, our password, and our confirmed password. So not only did we just confirm that we can get access to those values that eventually we want to send up to the server, we also confirmed that when I click create account, something is happening, right? We kind of jacked into that on click. Okay, great. Now let's make our API call. Now, what we could do is type out our fetch and, you know, do application headers, but we already did the hard work once. Let's just copy and paste it. But instead of going to test, we are going to go to an endpoint, create account. We're still going to post. And what do we want to post? Well, we want to post 3 things. We want to post our username. And where's our username coming from? It's coming from this.state.username. And what else do we want to post? Well, we want to post this.state.password. Now, what are your thoughts on confirm password? Should we send confirm password up to the server, or should we check that in the front end, right?
Server.
So in this case, we are going to do, always got to be the rebel.
I thought it was right.
So we're going to check it in the front end. And the reason for that is you never trust the client, right? You never trust the data that's coming from them. So if they said, oh, you know what, I'm going to change my password and my old password is 123. You don't just go, oh, well, I think your password's 123, so that's fine. Let me go change your new one. That you're definitely going to want to do server side. But in this case, the only point of confirm password is to make sure that they didn't fat finger something when they were typing it in and have a typo, right? So there's no reason why we can't check that on the front end. Okay, so what we're going to do is we are going to say, before our fetch, we're not done with the fetch yet, but that's okay. If this.state.password does not equal this.state.confirm password, we are going to alert the user passwords do not match. Okay, let's see what other things could happen that we wouldn't want to make the API call. Yeah, if it's empty, if there is not a this.state.password, or if there isn't a this.state.username, or there isn't a this.state.confirm password, we are going to alert the user missing form fields. Else, we want to make the API call. Okay. Haven't gotten to the back end yet, but that's all right. So what I'm going to do is I'm going to pop in here, and before we get too far, we're going to test. So we are going to just hit create account, and it says missing form fields. Okay, great. Now we're going to type in A and hit create account, and we're still missing form fields. Okay. I'm testing every possibility here, right? I'm trying to be the user who's just going to break the system. I'm going to type in something there, and now I get passwords do not match. Okay. I'm going to do it one more time, and I'm going to hit create account. Well, that's interesting. I wasn't expecting that to happen. We are missing form fields. So what we said is, if there is not a this.state.password, or there is a this.state.username, or there is a this.state.password, I didn't put in the not. Okay. You guys have to understand, when I make mistakes, they're totally planned, right? You got to see the debugging process. we are going to now type in all valid things and hit create account, and we get a different error. We always celebrate different errors, right? So what it's saying is it can't find 404 on the create account on the back end. Okay, well let's fix that. So I'm going to just console log out any data coming back from the server, because we're not going to be sending world back from the server. And I'm also going to come up here to my component did mount, and I'm just going to comment this out, right? We were just playing around making sure we could get to the server. I don't need to console log out test every time I turn on my server or load the React page. Okay, I'm also going to comment out my test endpoint here, and I'm going to make a new one. And we're going to go to our front end code, and we're doing a post to create account, which is probably what we want to do, right? We're creating something new. So I'm going to app.post, and I'm going to post to create account, and we're going to put our two favorite words in, rec and res. And before I get too far, I'm going to res.send. I should fill that in down the road. I should put a message in it, but before I forget it, I'm gonna put it in there, because otherwise we're gonna do a request to create account, and we're gonna post up to it, and the server can do whatever it wants, and the front end is gonna be like, hello, anyone forgot about me? And eventually it will time out. So this res.send, even if we put nothing in it, we're just telling the front end that the back end heard you, and it's done doing whatever it's supposed to do. Okay. What do we need to do here? What should create account do? Exactly, and how are we going to send to the database? Yep, so we already have our table kind of created for us in models, which is super convenient. And would you look at that, it's storing username and password for us. That's awesome. So what we're going to do is we are going to say models.user, and VS Code's helping us out here. Let's not fight it. .create. And what do we want to create? Well, we want to create the user with a username. And where are we getting the username from? Close. Rec.body, right? Because the information is coming up. Res is anything we're sending through to the server afterwards. Rec is what's coming into the server. Okay, rec.body.username, and our password is going to be rec.body.password. And how do we know username and password are coming up? Because if we go back to our front end, we are passing up username and password. And that just so happens to be coming from the state, but we don't care about that because we're in backend now. So we have our models.user.create. Now we have one problem here. Well, you know what? Let's see if this is working first of all, before we get too far ahead of ourselves. So I'm going to save, the server is going to reboot. I'm going to type in a username of 1, and my password is going to be very secure 2. I'm going to hit create account, and we get unexpected end of JSON input. So something blew up somewhere, but let's figure out where. I'm going to open up pSQL, and I'm going to go to my models file, and I'm going to see that the database we are connected to is video tutorial. Can you tell what files I was recording when I set up the video earlier? That's fine, we can use that. So we're going to go to username is still going to be Max Matthews because that's what the username is in our SQL file. And our database is going to be video tutorial. So we're going to connect in. We have our users table, and look, we have some data in it. I wish I could blow that up on the screen. I'm sorry I can't. But we do have our username and password that's saved to the database. So we know the data got uploaded properly, and we know the models.create worked. What didn't work? Well, we in our front end said, hey, once you're done doing that, then some JSON is going to come back, parse it out. So if we look at our front end, well, our front end is just res.sending. It's not sending back anything. It's just sending back null. It's sending back, okay, here you go. But there's nothing, no data in it. So all we need to do in here is say message user created. We just need to send back some JSON. We could even send back an empty object. It just has to be some JSON. So I'm going to save here. I'm going to go back. I'm going to refresh. I'm going to make my username is 2 and my password is super secure 3. I'm going to hit create account. And what do we see here? Message user created. But we never trust the front end. So we're going to go back to the database. We're going to hit the refresh button here, and we see our username and password were created.
Wasn't there like types for that? Like, did it usually have to be a string?
Yes, for saving it into the database. So there's no reason why you're saying, like, why did it allow it to save 2?
Yeah, like a number in the username.
Yeah, so let's go right into the browser. And I'm going to console.log. We're going to do a throwback here. Type of 2. And type of 2 comes back as a number. Okay, great. Now, what if we do type of 2 in quotes? It's a string. Is that a valid string? Can I put 2 in a quote? So that's what the database is doing. Is it's going, I don't care what's actually in here. Are you putting in a string? And if you're shoving in a string, then that's fine. So when we are working here in our app.js, whenever we call setState, event.target.value is a string. So it's passing that into the state. Then the API call is happening. It's pulling that string out of the state. Then it's going up to the server is grabbing it, putting that into the database is getting it, and throughout that whole process, because we're using JSON, it's a string. Now, if we didn't use JSON, we could get ugly with file formats, and it might not know it's a string, and you might have what they call coercion, where you're forcing a number into a string. But in this situation, because this input type is text, all the way through, it goes, got it, it's a string, no problem. Okay, so we just created our first auth system. Yay! We can create as many accounts as we want. Should probably set up a way to check to see if who you're saying you are actually matches with what's in the database. Okay, so we have our create account. What should we do now? Well, in order to check to see if you are who you say you are, we probably need to give you an opportunity to say who you are. So what we're going to do is we are going to create a new form for logging in. Now, we could just throw this underneath everything, or we could use a row and a col and put all of create account in one column and all of login in another column. So we're going to scroll down here. We're going to throw our row and col in. We're going to save and just make sure that we didn't break anything. Still looks good. Great. What we are going to do is now in here, we're going to do a new call. And we are going to put a H3 in here that says login. And I've made this mistake plenty of times, looked at that one. That's simple code. That should all be fine. And go to my front end after writing 300 more lines of code and realize that I didn't put the closing tag in the right place and it looks horrific. So even though we only added a couple lines of code, I'm going to go back here and I'm going to make sure that login is at the right place. And this interface already looks 10 times better because these form fields aren't huge, right? Great. So we could go in here and we could make our new form tag and we could do our input type text and all of that stuff. But we've already done that work. We have our username and password. So I'm going to copy that. I'm going to throw that in my form. And I'm going to grab my button while we're at it. And I'm going to copy that. And I'm going to paste that. And I'm going to think that I am so smart because I just saved myself from writing all those lines. I'm going to go in here. I'm going to be so happy about it. I'm going to type in my username and oh God. All right, well, that can't happen on, oh crap. All right, so copying and pasting is great. But what we need to do here is go to our value. And instead of calling it password, I'm going to call it login password. And then on my on change, I am going to grab the event like I did before. I'm going to this.set state to my login password to my event.target.value. And my username is going to point at login username. And my on change is going to look at login username as well. Now, if I was truly being good, I would go up and change all my change passwords to have change password or change username or I'm sorry, create username, create password. But because they are different, we're okay now. Before I jump out of here, have a red squiggly. So my eye just jumped to that immediately. And before I even got to the browser, I was like, oh, something's wrong. So I'm just going to delete that one out. Great. I'm going to hop in back to my browser. Woo. Okay, we got a bunch of errors. And if I go in here, it's still typing, it's still working, but I care because it's red. You notice we have some yellow ones up here that are still hanging out from yesterday. Before we deploy, before we go to production, we should probably solve the yellow ones. But what I care about is red. So our red here says a component is changing an uncontrolled input of type text to be controlled. So all that's saying is that I went and I tried to find login password and you didn't tell me what it was. So I just went, okay, that's uncontrolled. I don't care about that. You can type in whatever you want. But then this on change happened and we set in login password and all of a sudden it went, whoa, all of a sudden login password has a value. You're confusing me. It's uncontrolled because you didn't tell me what the value was. And now all of a sudden it's controlled because login password exists. So what we're going to do is we're going to go back up to the top here and we just need to tell it that login username is starting out as empty and that login password is also starting out as empty. So now we can go back into our code. We can type ABC. We can type in our password and we get no red. Great. What's next? Yep.
Or the server first.
Yeah, so we can't get to the database without the server, right? So we are going to jump in to our bottom here. And instead of on-click create account, on this time, we're going to on-click login. Okay. And we're going to take our whole create account because all of this code is pretty similar. Now, we don't need to check to see if the confirm password matches the other password. So we're just going to nuke that out. And we don't care if confirm password is empty, but we should probably check to see if login username is empty and if login password is empty. And if it is, still let them know they have missing form fields. Okay. If it's not, we want to log in. Now it's still going to be a post request because we want to send up some data in the body. Now our username and password, those can be the same, right? Because once it gets to the server doesn't care where it's coming from. But in here, we need to change it to login username and login password. Otherwise, you could type in whatever you wanted here, and as soon as you hit login, it would go, I don't care about this stuff. All I care about is these values over here. All right, now that we're in here, we are going to get some JSON back, and we're going to console log it out. All right, all of that's great. Let's go make login happen. So we're going to go to our index.js. We're going to do a new app.post. Call it login. We're going to do our rec res. What do you think we want to do in here? Res.send before we forget? Sure.
We want to make sure the login password, create password,
Mm-hmm.
password,
Mm-hmm.
match.
Yep. And in order to check to see if they match, where do we get that information from? The models, the database, right? So how do we access the models? models.user
That's fine.
find. And I'm going to use find one. So basically, instead of it returning an array of all the things it found, we are going to only return the one thing, the first thing that it matches. Now, we should probably go in here and get fancier and make sure that there are no duplicate usernames before it creates an account, and make sure that password meets certain requirements. So here's an example of when you would want to do it server side instead of doing it client side. If I have a requirement that passwords must be 6 characters long, I could check that on the front end and let the user know, hey, your password isn't 6 characters long, please make it 6 characters long. But the end user could get fancy and look at the network request and go, well, I can make a post request to that, and I can make my password only 3 characters long. And if the server isn't checking the password length, it would then go ahead and let you create that password. So it is very common to not only do server-side validation, which is the important one, right? Because that's what's going to prevent an end user from kind of gaming your system and doing it server-side. But you also probably want to do it client-side, because they don't need to make an API request and run through all of your backend code if you catch them before that happens and say, hey, you need a longer password. But you also want to do it server-side, because those hackers are going to want to try and backdoor into your system and get around some requirement. And so you also need to do it server-side. But yeah.
You mean backdoor, you just mean like something that they forgot to check for? Or like
yeah, so I can open up Postman. Here's a great example. So we did all of the logic in the front end, right, to make sure they couldn't create an account if username or password were empty. But there's nothing stopping me from opening Postman and saying, hey, post to localhost 5000, right? Go to our backend, and they can open up the network tab right in here and see what happens if I create 3 with a password of 4 and a password of 5. It says missing form fields, right? They don't match. So if I go back and I make a match and I hit create account, I still have missing form fields. I broke something. So let's go back to our front end. And what we said in create account is check to make sure the passwords don't match, and check if any of them are empty. So I'm looking at this code, I'm scratching my head and going, it's just working. Okay, so sometimes you need to take a step back, and instead of going, why is it broken? It's sometimes easier to say, what did I change, right? So I'm gonna scroll down here, and I have my create account, and it's doing all this cool stuff, and it's posting to create account, and then I have create account again, and it's posting to login. So when I copied and pasted all of that code, I forgot to change that to login. So what it was doing was, I don't care about your create account. You made a new create account, so I'm going to listen to that one. And that one is checking login password and login username. So go back to our code, and I'm going to say, all right, the username is 3, the password is 4. I'm going to hit create account, and in theory that worked, right? I have my message user created in my console. But as a smart developer, I'm going to try and break my own code. Well, I can go to network and look at create account and see that it made a post request. And I can scroll down here and I can see that it sent up the username and the password. So I can do that. I'm going to go to Postman. I'm going to make a request to localhost 5000, and I'm going to say create account. And I'm going to go to my body, and I'm going to say it's raw, and I'm going to say it's JSON, all things that I can find from my network tab. And I'm going to post up a username of nothing. And I'm going to post up a password, oops, quotes, because we're in JSON, of haha, you are insecure. And I'm going to send, and I get message user created. And so now I'm going to go to my SQL, not SQL Pro. I'm going to go to pSQL, and I'm going to refresh, and I have an empty username. And I have, haha, you are insecure. So if we tried to do that in here, right, and we said username is blank and created in a password, it's going to say missing form fields, and it's not going to create that. So I have actually gamed the system. I'm not saying this on a recording, but when the iPhone maybe 7 launched, they had limited inventory, right? And so I went in to pre-order my iPhone, and it said no more inventory at this store. And I was like, let me go to that network tab, right? And I saw the API call happening, and I saw that it was coming back with no inventory. And I'm like, okay, but what happens if I go in and change the response of that API call? And I went in and I said, oh, inventory available is now set to true instead of false. And I hit the button and it went, congratulations, give us your credit card information. And so I went, there's no way this is going to work, right? Like I was up at like 3 a.m. pushing this through, just looking at the network tab. And sure enough, I got the email that my iPhone had been ordered. And a week later, I went to pick it up, and they at the store couldn't figure out how I had gotten my order in, because they weren't supposed to have any inventory for this. But Apple had the order. So the order, if the order went through, they had to have the inventory. So they sent the inventory to the store. That was not a widely reported thing. It's not like I looked that up and found it. I tried to do that trick next year, and somehow they figured out and made sure that before the order could go through, they would check inventory again. And that's something that can happen a lot of different ways. It doesn't necessarily have to be a hacker. I built a system in college for signing up for shifts. And some of these shifts, I worked in theater, and some of them were working with Oprah or Seth Meyers or Kate McKinnon or the Dalai Lama or all these high profile names, right? And so the admins, the people posting the shifts, would go in and create the shift, and they would say it's posting at 12. So everyone has to be on their computer and they have to be hitting the refresh button. Well, all the students would go on and try and sign up for that shift. But I only checked when the page loaded to see if the shift was available. I didn't check to see when I actually submitted the request to see if that availability was still there. And so students would load the page, and as long as they loaded the page while there was availability, they could go for a walk, they could do whatever, they could come back 15 minutes later, and even if the database itself said there's no more availability, they could still click the button and get that shift. So what I had to do is say, okay, no, don't just figure out whether it's available or not when you load the page. When they actually click the button and hit the submit, check to see it's available when they go to sign up for it. And in my head as a developer, I thought nothing of that, right? I thought, oh, just they check the availability when the page loads, so it must still be available. I didn't think to do it a second time when it actually mattered when they signed up for it. So I had to go in there and not only do that, but then also add logging, not at the second level, but at the microsecond level to see when people actually hit the sign up button. So just things to think about. So what we can do to fix this is we can go to our server-side code, and in here we can say if there is not a rec.body.username, or there isn't a rec.body.password, res.send hackers, you get nothing. Else, go ahead and create the user account and all that stuff. So I'm going to go here. I'm going to hit create account. I'm still going to get the front end block, but if I go back to my Postman and say that I'm really insecure and hit send, I'm going to get my hackers you get nothing error, and I can go to pSQL and I can refresh. I still have the old one that I created before, but I'm not getting a new user in there. And we can do one more thing. We can make our code even more clear, because when you get the message back, the browser gets that, it goes, hackers, you get nothing, but it goes 200, everything's fine. So in my backend code, instead of just sending you get nothing, which is going to default to 200, I can actually set the status to 401, and 401 is normally unauthorized. So when I go to my Postman and I hit send, I get my you get nothing back, but my status is set to 401 unauthorized. And if I did that in the browser, I would get a red line in my console that's letting me know that API call failed. All right, little tangent. Back to login. So our login, we need to find some user. How are we going to find the user? What's that? I feel like sounds came out of your mouth, but not words. Match username, exactly. So we're going to say, hey, go look in the database for username. And where are we going to look for that username? We're going to look in rec.body.username. And what we're going to do is we're just going to console.log all of that.
So people has key value pairs too.
Correct.
Wait, so it's gonna use, so find one is gonna take, it's saying, hey, keys username, find what username.
Yep. Rec.body's coming from the front end, right? So it's saying whatever username was typed in and they hit sign in for, that's going to have a fetch. The fetch is going to go to the post login. The post login is going to go, all right, what do you want to do? I want to go to the models user. I want to go to the database table. I want to find one. I don't care how many things you match, because theoretically there should only be one account per username, which we would handle in create account, but we're not going to go down that far. So we're going to look in models user, and we're going to find just one of them. And what do you want to find it on? How do you want to find it? Well, I want to look in the username column. And what username do I want to look for? I want to look for whatever came in rec.body.username. So if I wanted to, if I wanted to look up user1, I could do that. But instead, I'm going to just do rec.body.username because I want to look at what actually got uploaded. Okay, we're not going to get anything fancy. We just want to make sure that something's coming back from the database. So we're going to go in here. We're going to type in username ABC. We're going to type in some password. We're going to hit login. And okay, no errors. Console looks good. It got the res.send back. So let's look in our console here. And what do we have? We have a promise. Okay, so what we just did is ask the database to find my user by the username, and it went, okay, I promise I'll do that. Well, we want it. So what we have to do is we have to tell the code, hey, what we're going to do is going to be something asynchronous here, right? The database is going to run this code, and we want it to wait for it to find that. So you can hold off everything else. Don't res.send until we wait for the database to send the username back. So what's happening without this async and await is the database is actually finding it, but by the time it finds it, the res.send is sent, and that's it, it's over. So what we need to do is say, hey, this code that we're looking for, this user, is mission critical. We can't log the user in until we find out if that user exists in the database. So just pause, hold up. We will wait for you. Go out and get it. The database comes back and it goes, all right, I promise I'll go do that. And then it hits the await. And then the database goes, okay, crap, I have to go actually do that. You need this data. It pauses, it waits for the database to get that. It returns it back in. And then it goes, okay, now what do you want to do with it? And we console log it, it console logs out, and all of our code goes on its merry way. So I'm going to go back here. We're going to hit login again. We get this empty object back. But when we look in our console, holy Djibouti, we got users back. I don't know why I just said that. But we have some data values in there, and we have the ID and the username and the password. okay, that's cool, but we can test for some more things. I'm just going to put a bunch of enters in my terminal. And instead of looking for ABC, we're going to look for XYZ. And when I hit login, still the empty object. We haven't done anything on the front end yet, but I'm going to come back here and we have some user data values again, and it found username 1. Okay, well, if we scroll back up, it's also finding username 1. So something's not right. It shouldn't be finding the user with the username of 1. It should be not finding anything, right? We don't have a user with the username ABC. Okay, so we've got a problem. So what we're going to do is we are going to console.log out our rec.body.username. And I'm just going to console out the database find. I want to see what's getting uploaded to the server. So I'm going to go back here. I'm going to hit login. Again, we still don't have anything, but when we come back here and scroll all the way down, XYZ comes out. So XYZ is getting sent properly from the front end to the back end, but we still have some problem. It's still matching when it shouldn't be. So I'm going to go to my models.js and I'm going to look at my user, and I have my username and it's equal to a string. Okay. I just figured out what the problem is, but this was totally planned the whole time. So XYZ is going in there and it's getting that thing, it's getting something that doesn't match XYZ. So let's look at what it's getting. I'm going to hit login again. And I'm going to scroll up and it's getting username 1 and password 2. Okay. I'm going to look in my database, and what I think is happening is even though it's pulling this record, it's really confused that username is empty. It really does not like that. So I'm going to just hit delete on that value because we already plugged that bug, right? I'm going to save again, and I'm going to go in here and I'm going to log in and I'm going to look in my back end, and it's still finding 1 and 2. Okay. So instead of just telling you the answer, I'm going to tell you how I figured out the answer. I'm going to go to this equalized documentation, and I'm going to go like, what the heck? I need to be able to find things in my database where only one condition is true. Where only one condition is true. Can someone just check the live stream for me and make sure I'm still streaming?
Yeah.
Okay, thanks. Okay, well, I want to query the database and find all, that's great, and it's using some attributes. Okay, that's great. I'm going to scroll down a little bit because what I want to do is find one or find all where something is true. So I'm going to look at my find all that's running, and they pass in the key just like I do. But you notice this little important line right there that says where? Maybe I should look at my code and see, I'm going to find one username.
Oh.
No. I'm going to find one where the username is rec.body.username. Okay, I'm going to save that. I'm going to go back here. First of all, I'm just going to put some enters in my terminal so I can see what the old code is, what the new code is. I'm going to go back here. I'm going to sign in with XYZ, and I get null. Okay, now I'm going to go back here, and I'm going to sign in with my username as 1. And I got a bunch of things from the database. Okay, so we're making progress. We are going to, instead of console logging it, we are going to store that in a variable called userdb. Okay? Now, we just hit the first case of when we shouldn't log a user in. We're going to hit a lot more of them. What's the first thing we should do after we run the database query? I'm going to go in here and I'm going to sign in with 1, and that's fine. Now we need to go do other things. But if I sign in with ABC and we scroll down here and null comes out, I don't need to check. You have to tell them. I don't need to check to see if your password is right. I don't need to check to see if it's encrypted. I don't need to check anything. All I need to know is that the user doesn't exist, right? Now, you would think you want to tell them, hey, the user doesn't exist. But what you really want to tell them is account credential check failed. And the reason you want to do that is because you are now basically telling every hacker what accounts exist and what accounts do not exist. So now, instead of just trying every combination of every username and password, they can try whatever username they want and see if that username exists. And if that username does exist, now all they have to do is crack the password.
Well, I can't do that. Like, if you're signing up for something, you do the same thing. You put in a bunch of usernames and see if they're already created or not.
You can. And there are some clever ways of getting around that. You should use reCAPTCHA, first of all, which is, like prove that you're not a robot. The other things you can do is like check to see username and username and email and make sure that the email they're signing up with is valid. The main way to get around it is just to rate limit them. So say, hey, if you're trying to sign into 100 different usernames in under 60 seconds, you're probably not a real user, right? So what we are going to do is, instead of just sending back a very specific error, like username is incorrect, we're just going to send back an error that says check credentials. And we're going to do that if the password doesn't match. We're going to do that if the username doesn't match. We're going to do that pretty much whatever is wrong. We're just going to say, hey, something's not right. Okay, so what we are going to do is say, hey, if there's not a user in the database, we are going to res.send error can't sign in. Okay. Now that's great. We're sending something back. Before we go too far and build out all of this different authorization logic, let's handle that in the front end, because it's very easy to send back a bunch of different things and then forget to tell the actual end user that, right? Because if we go in here and hit login, the error can't sign in shows up in the console, but the end user never knows that something is wrong. So we're gonna go back to our, oh, I did not mean to do that, sorry. We're going to go back to our app.js, and in our console log data, we're going to say if there is a data.error, then this.setState error to data.error. Okay, what the heck did I just do there? What I did is I passed in some data to the state that we can then render out. So what I'm going to do is I'm going to come down here, and at the top of my login column, I am going to say, if there is this.state.error, show the error in a p tag that says this.state.error. And let's just get fancy for the heck of it and say style equals color red. And if there's not an error, don't show anything, just make it null. Okay, so we're going to come back here. We're going to type in ABC. We're going to type in some random password. We're going to hit login, and we see can't sign in right there. So let's go through that flow one more time, because it's hitting more steps than you might think. So we have our form. We click the login button. That's going to fire the on click. The on click is going to, if you hold in command and click on login here, it's going to jump, Visual Studio Code is going to jump you right up to where login is. So I can command click on it. It takes me right up to the login. It's going to check to make sure that the login password and the login username are not empty. It's not, so it's going to make a fetch request. That fetch request is going to have some JSON content with our username and password in the state. Okay, we're going to go here. We're going to look at our login. The login is going to pull the username from the body that got sent up in the fetch request, and it's going to save that in UserDB. And we're going to wait for the database to return that information before we operate with it. Okay, what we are going to do is we're going to see if the user database does not exist, we are going to res.send cannot sign in. And I'm just going to throw this in an else because we don't need to do this if the user doesn't exist. We'll get into that more in a second. Okay, the user doesn't exist, so it's going to send back an error that says cannot sign in. So we're going to trace that back to our app.js. Our app.js is going to get that back as a string, and it's going to go, okay, that's some JSON. Let's parse that out so you can access that data. We parse out the JSON. We go into the data. And what we are going to do here is we're going to say, okay, if there is an error, we are going to set state, and we're going to set the state to whatever the contents of data.error is. Okay, now that's in state. Well, because we set state, render is going to run again. So we're going to come down to the render, and the render in our login code is going to say, hey, is there some error in the state? And if there is some error, show this p tag. Okay, and what is that p tag going to show? It's going to show whatever the contents of error is in state. So that comes from all the way back in our backend code where we have can't sign in. Okay, and in our app.js, if there is not an error, we're not going to show anything. Okay, well, there is an error. So when we look in our browser, that's how we get can't sign in from the login button, going all the way up to the back end, doing things in the database, operating on the database, sending that message back down to our login function in React. And our login function is then passing that data into our render function. It's a lot. That's what it means to be full stack. Okay. So the only other thing we need to do is check the password, and then we're going to take a break. Okay. So we are going to go back to our backend code, and we handled if the user database doesn't exist. So what if, or the user in the database doesn't exist? So now that we're here, we need to check if the password matches. So if userdb.password equals the rec.body.password that we sent up, res.send message party parrot. I mean, message user is signed in. Else, res.send an error can't sign in. Now I'm going to delete this res.send here. Now I'm only comfortable deleting this because there is no logical condition where nothing can send back from the database, right? And what I mean by that is if there's not a user in the database, something sends in. But if there is a user in the database, then check their password. If their password doesn't match, we're sending something. If the password does match, we are also sending something, right? So you should never be making a fetch or an API call without returning something from the server. But no matter what we do here, no matter what conditions happen, we are still sending something back to the server. Okay. So I'm going to hit the login button here, and I still get my error can't sign in because it can't find the username ABC. So I'm going to look in my database and remind myself of what passwords I set in pSQL. And I have a username of 1 and a password of 2. Okay, so if I sign in with 1 and my password set to ABC and I hit login, I get blank. Well, I don't want it to be blank. I want it to have an error can't sign in. So I'm going to go back here, and I'm going to notice that I have this lovely dot sitting on my index.js, which means I forgot to save. So I'm going to come back here. I'm going to refresh. I'm going to type in my username as 1. I'm going to type in my password as ABC. I get my error can't sign in, and it still shows up there. Great. Now I'm going to type in my password as 2, which is what we have very securely, air quotes, stored in the database. I'm going to hit login and I get message user is signed in. Awesome. Now we have one more problem. We have this red can't sign in. Okay, well, if we refresh and type in our username is 1 and our password is 2, it doesn't show up and we get the message down here. What's happening is that when we sign in wrong, it has can't sign in. But when we sign in correctly, that can't sign in is still in the state. It went, oh, there's still an error. So what we're going to do is we are going to come back here in our front end code and go up to our login. And what we're going to do is say, okay, if there's an error coming back, set the state to error. Else, this dot set state error to null. Clear out the error. So if they sign in wrong, they get the error. They sign in again, and there's no error. Clear out the error that is in state. So we're going to refresh. We're going to sign in wrong. We get our can't sign in error. Obviously, we should spoof that up and make that a little bit more obvious, but for now, it's fine. And if I sign in with the correct password, thank you. If I sign in with the wrong password, I get my can't sign in. If I sign in with the correct password, my error goes away and we have user signed in. Awesome. So now we need to do some more things. We need to make the login go away, or we need to, redirect to a different page, whatever it may be. But for the most part, this is all we're going to do in our front end. And the reason for that is because what we just did in the back end would get you arrested by the Seattle police for leaking credit cards from Capital One. Right. We are doing so many insecure things here that the point of the front end is just to get something working, is just to kind of reinforce that our front end is talking to our back end, is getting stuff from the database. That whole flow is working. Now we get to look at the kind of the guts of authentication and go, all right, let's have some fun and let's encrypt that. Okay, now what's the problem with this encryption? Okay, let's encrypt that a little bit more securely. Okay, now what's the problem with it? So that's what we're going to dive into after the break. Any questions? Okay. Is everyone okay with kind of everyone following along? Anyone wish they were coding as I did it? A little? Okay. There were days that I wish I had 2 or 3 brains at work as well. So that's not something that goes away when you get more experience. Yeah.
Would it be possible to I know there's 3 different levels to this, instead of going through all 3 levels and then having us kind of catch up. Can we catch up at each level?
Yep. So
that's okay with everyone?
Let's take a break now. I will share this code as a VS Code live session thing. We won't continue until people are comfortable and caught up to this point, which I think is great feedback and a great idea. So feel free to take a break or feel free to work on the code now. And then we will jump back into this once everyone's caught up. if when you guys watched the video, you could hear and see what I was doing.
Yes.
Okay, so this is part of the problem that happened at the Capital One breach, was that people had access to the database, and that database had the information just sitting out in the raw. It wasn't encrypted. So what we are going to do is do the first step of encryption, right? And the big thing with hashing in particular is that it's one way, right? So once you encrypt the data, you can never decrypt the data if it is a hash, right? It just dumps out what looks like a jumble. And if you go, okay, well, how does that work? If it's a jumble, then how do we check to see if they signed in with the right password? Well, the thing with a hash is that whenever you use an input, it always produces the same output. So it doesn't matter how many times you put in the input, if that input is the same every time, it is always going to produce the same hash. But if we take that hash without knowing the input and say, okay, reverse that, the hashing algorithm goes, I can't do that. This is only one way. So what we are going to do is we are going to stop our server in the backend, and we are going to run npm install -- save, and we are going to install MD5. Now, anyone watching the stream who gets comfortable with security will rewatch the stream in a year and go, oh my God, I can't believe he's using MD5. MD5 is no longer considered a secure hash, but we're going to start there, and I'm going to show you why. So our MD5 is installed with npm. So we are going to run npm start again and get our server back up and running. And in our backend code, I am going to const MD5 equals require MD5. And MD5 is a package, right? That's why we're requiring it in. But two, it is an encryption hashing algorithm. So when it came out, it was said that anything you put in MD5 cannot get taken out of MD5 unless you match it to the original. So what we're going to do before we even get into an endpoint, we're just going to console.log MD5 hello world. Okay, and we're going to save that. And if we look in our console, we have this 5EB63BBE, all that stuff, right? All of these SQL commands in the terminal are going to drive me crazy because I can't see what's actually happening. So what I'm going to do is I'm going to go to my models, and in my options, I'm just going to say logging is false. And that just turns off all the SQL commands. So all the SQL commands are still running. It's just not dumping them out into the log for us. Okay, so we have this 5EB63BB whatever. That is the hash. So there should theoretically, with a good hashing algorithm, be no way to find out what that is. So if we go back to our index and we change it to just hello, we're going to see the hash comes out differently, right? It's 5D blah, 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 blah. But if we change it back to hello world, it's going to go back to 5B63BBE. Okay, so
That seems like the secret code you used to write when you were a kid with your friends.
it is
Everything has the same, like every time it's the same.
the difference is when it's a code with your friend, it can be reversed, right? So you can, instead of knowing the output, you can just go match the output back up to the input and figure out what it is. With the hash, it should be one way. So you shouldn't be able to take that and convert it back. So we are going to go to Google, and we are going to just do a search for that. MD5 reverse. Oh, well, that's not good. It figured out it was hello world. Okay, well, that's an obvious one. I'm sure we can get more secure here. Let's say password 1. I'm sure Google's not going to know what password 1 is. Okay, Google knew what password 1 was. All right, well, I'm just gonna do random. Okay, I'm gonna go back here, I'm gonna reverse. Okay, so it didn't find it. So there are times that Google's not going to have those answers, but what happened was MD5 got cracked and they figured out what they call a collision. So the other thing with hashing is not only is it one way, and not only do you get the same thing every time you put in a password, but it also should be unique. So if I put in hello, what it returns out should be different than if I put in hello world, right? And what they found was running these random things over and over and over again, they actually found a collision. They actually found that if they typed in 1, 2, 3 and did the MD5 hash for that, something much more complex than 1, 2, 3, and they ran a different string through it, they got the same answer back out of it. And so when you find that collision, you can figure out how the algorithm works. And so MD5, for that very reason, is no longer considered secure. However, we are going to start with MD5 and we're going to work our way up from there. So what we're going to do, that's great. We played around with console. We have the package installed. Now let's actually use it, right? So we're going to go down to create account. And what we're going to do is instead of just throwing the rec.body.password in, we are going to throw in MD5 rec.body.password. Okay. So I'm going to go to my front end code and I'm going to make my username ABC and my password is going to be a super secure 1, 2, 3. Okay, I'm going to make my password 1, 2, 3 again. I hit create account. It says user created. Now I can go to my pSQL and refresh and I have ABC and I have this random thing in the database. Great, we hashed it. So I'm going to go back here. I'm going to type in ABC as my username. I'm going to type in 1, 2, 3 as my password, and I get can't sign it. Okay, well, we hashed it going into the database and saving it in the database, but now we're pulling it out, and our code is going 1, 2, 3. 1, 2, 3 doesn't equal 202 CB96, blah, 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 blah. So we can't just say, oh, reverse that hash and see if it matches. But what we can do is say, hey, hash whatever password you upload, hash what the input is, and then see if that hash matches the hash that we have in the database. Okay. So instead of seeing if userdb.password equals rec.body.password, all we are going to do is put this in MD5. So now when we save and we hit login, it says user signed in. But we have to make sure that it still works even if it's not true, because we could be getting a false positive here, right? So I'm going to change my password to 1, 2, 3, 4 and hit login. And now we have can't sign it. Okay, cool. Now the issue is that I could take this password and go to Google and find it, right? Which we have kind of already proved. So maybe this was a bad website to pick because they have a bunch of ads. Okay, so the hash that I just copied from the database is 1, 2, 3 decrypted, right? And the issue with any hashing algorithm is that I could make my password Thriller, right? Which was the example they used in the YouTube video before. And even if that hashing algorithm is super secure, the issue is that another user might make their password Thriller. And that user may have had their password hint set to Michael Jackson famous song, right? So what I can do is now not only figure out what that password hash equals to, I can figure out that any other user with that same exact hash has the password Thriller. Okay, so that's problematic. So what we're going to do is use a salt. And the salt is going to take the user's password and add 3 random letters to it. And we're going to remember what those 3 random letters are. So when they re-enter their password, we're going to add in the salt and then see if it matches the hash. Okay, so let's see how that works. I know that's a lot of theoreticals, but what I'm going to do is I'm going to come down here and I'm going to npm install -- save as always, and I am going to install crypto random string. Now, we could write our own random function here to return a string that's 3 or 5 or 10 characters long. But in today's modern world of development, someone has already done it for us, and that's the package crypto random string. So I'm going to start the server back up with npm start, and I am going to const crypto random string equals require crypto random string. And then just to make sure it's working, I'm going to console log crypto random string and then 3, which is going to be the length of the string. And it crashes immediately. This is why we test before we assume that it's going to work. So crypto random string, I believe, requires length to be passed in as an object. And out came 142. And if I stop the server and start it back up, df8 comes out. Now you might say, Max, how did you know how to fix that? And that has nothing to do with the prep work that I did earlier. I'm going to go to npm and I'm going to do a quick search for crypto random string. And the one with 4 million downloads this week has usage examples of how to use it and the fact that you pass in length. Okay, great. Now, like I said, we could write our own random function if we wanted to, but someone else has just done it for us. So I'm going to copy that code and delete out my console log. And what we are going to say is, hey, when we create a user, we want to generate the salt for them. So we are going to say const salt equals that random string. Okay. Now I am going to take their password and we are going to call it generated password. And now let's tell it how we're going to generate the password. So we're going to say const generated password is equal to an MD5. And we're going to take the password that they uploaded and add our salt to the end of it. Okay. Now we need our salt down the road, and we're going to see that in a second. So in addition to storing the password, which is now salted, we are also going to store the salt that we generated. Okay. So we're going to save that. We're going to go back here and we're going to create a new user. And it's going to be ABC1 and the password's going to be 1234 and the password's going to be 1234. So I'm going to hit create account and user is created. Great. And I'm going to go into my P-SQL. I want to make sure it's still created. And there's my ABC1. It stored my salt as 910 and it stored this random password. Now I'm going to create ABC2 with the same exact password and hit create account. When we look in our database, that password hash is different now. Why is it different? Well, because it's not just 1234 anymore, it's 1234 plus F4B, right? So we can create as many user accounts as we want, and because the salts are different, the hashing will always return something different. So now, if I take this and Google it, even though my password is 1234, which definitely is something that Google would normally return, when I go in here and stick in the hash, it can't find it.
So you said that the hashes for 1234
are findable.
Are different.
Well, no, the hash is always the same.
The hash is always the same.
But because we added something to the password. So we took 1, 2, 3, 4, and we added 910 to it.
Right. So the hash is the same, but the salt is different. Or did you?
The hash is now different because
you added the salt.
because we added the salt.
Okay.
So the hashing is the encryption process. right?
That hash is a type of encryption, yes.
And then the salt is just like stores the encryption.
Okay, so what's happening is we are,
It's like, instead of your password being 1, 2, 3, 4, it's 1, 2, 3, 4 plus whatever the salt is that it added. But
Yes.
every time you pick the password 1, 2, 3, 4, the salt is gonna be different.
yep,
And then, so like, it doesn't matter, like, I could have 1, 2, 3, 4, you could have 1, 2, 3, 4, and like, Kelly could have 1, 2, 3, 4, but our salts are all gonna be different. So it makes the hash different, because it combines the salt and the password, and then it changes the hash algorithm, so it's not
Oh,
for
okay.
1, 2, 3, 4.
There you go. That's where the salt goes, yes. All right.
did everyone follow that?
Changes the flavor
No,
after.
I don't know. You did.
Okay, that's fine. Okay, so our password is 1, 2, 3, 4. And we take 1, 2, 3, 4 and we put it in MD5 and out comes ABC. Okay, and so every time we put 1, 2, 3, 4 into MD5, ABC is going to come out. All right, so now instead of putting in 1, 2, 3, 4 and getting out ABC every time, because now I can just find any user account that has ABC and know their password is 1, 2, 3, 4. Okay, so what we're going to do is we're going to take 1, 2, 3, 4, and we're going to generate some random thing, and that's the salt. And we're going to put 1, 2, 3, 4 XYZ, and then we are going to hash that. And because we're hashing it, we get out DEF. Okay, now another user comes along and says we are going to hash 1, 2, 3, 4, but we're going to generate another salt for them. And the salt we generate for them is HKL. We're going to add HKL to 1, 2, 3, 4, hash it, and what's going to come out is not ABC or DEF, it's JKL.
So it first, like, they take whatever the user puts in, and then it generates
A random thing to add on to their password.
and then it encrypts that.
Yes.
Yeah.
And then what comes out of the encryption is going to be different because that random thing we added. Okay, so now that we are here, we're going to go back in and I'm going to sign in with ABC1 and my password of 1, 2, 3, 4 and hit login, and it can't sign me in. Well, it can't sign me in because the login is taking my password without any of the salt added to it, and it's trying to compare the hash without the salt to the hash with the salt, and it's going, well, I can't do that. So what we have to do is, instead of just using rec.body.password, we need to add in our rec.body.salt.
That's so easy. Why do you make this look so easy?
So I'm going to hit save. I'm going to go back here. I'm going to refresh. I'm going to type in ABC1 and I'm going to type in 1, 2, 3, 4. And I'm going to log in and I can't sign in. So something's not right. What I'm going to do is make sure I'm not confusing myself, which I have been known to do. I'm going to delete everything out of my database and I'm going to create a new user. So ABC1, ABC1 is going to be the password and ABC1 is going to be the confirm password. We're going to create the account. We're going to make sure that it's in the database. It used the salt. Oh, I know what the problem is. Okay. We're going to sign in ABC1. We're going to sign in with ABC1. We're going to log in and we can't sign in. Okay, so let's look. We think everything's right in the database, right? Because we can see it's generating the password and the salt. So things seem to be right there. So let's look at our login code in particular. So log in, find the user in the database. Great. If there's not a user, can't sign in. So I'm going to put a console log here with just the number 1. So I know if that's where it's hitting. Now I'm also going to put a console.log2 and a console.log3 just to figure out what if statement it's breaking at. So I'm going to go back here. I'm going to hit login. I can't sign in, but I also see it's hitting 3. Okay, so should it be hitting 3? Well, no, I'm typing in the password that's supposed to match what's in the database. So, okay, what's happening here? User.db.password. Maybe the password's not coming back from the database. Maybe that's the issue. So I'm going to console.log userdb.password. I'm going to come in here. I'm going to hit login. Can't sign in. Okay. But 0f blah, blah, blah is coming back from the database. Okay, well, let's look in the database. And that is indeed the password that is set. Okay, so that's not the issue. Okay, maybe the issue is with my rec.body. Let's console log out my rec.body. Okay, I'm going to go here. I'm going to hit login. Can't sign in again. And the username and the password are being uploaded properly. Okay, so that's not the issue. So let's take a step back and think theoretically here. UserDB password, what is that in the database? That is the hash of the password and the salt added in together. Okay, what do we want to compare that to? We need to rebuild that, right, from the user data. So use MD5, and what do we want to put into the MD5? The rec.body.password that they uploaded, and the rec.body.salt that the user uploaded.
No, that's in the, oh, so do we need user DB?
Right? So sometimes it takes that level of going through and putting in the console logs and just going, this should be working. Why isn't this working? Right? And the user will never see their salt. If they see it, it's not a big deal. But when you're checking it on the back end, you're pulling the salt from the database and then comparing what they uploaded plus the salt hashed together to the hash that we already made in the database. Okay. Nope, I didn't mean to do that. So we are going to save. We're going to go back to our code. We're going to hit login, and user is signed in. Awesome. So let's add one more layer of security. And then as a compromise, I'm going to stop right at 8 o'clock. Hopefully I can do this in 3 minutes, and everyone can catch up. Okay. So what I'm going to do is I'm going to copy my login and my create account code. And I'm going to put it down here and just comment this out so you guys can practice with MD5 and creating your own hashes as well. So MD5 is great, but like I said, it got cracked, right? And people found very easy ways to figure out from the hash what the original string is. So there have been several different algorithms that have come after MD5. SHA-1 was the next popular one. Spoiler alert, it got cracked. So then they went in and went, well, if we can do it one time, we can do it 255 more times. So SHA-256 came out. SHA-256 is still considered pretty secure. There are a couple other ones out there like Blowfish. The most popular one we're going to use is one called Bcrypt. And the nice thing about Bcrypt is you may have, it's pretty popular. It is, the nice thing about Bcrypt is it takes care of the salting for you. And it does all kinds of really fancy stuff like taking your password, adding a salt to it, hashing it, and then doing that process 9 more times.
Did you use it when you were doing the bootstrap like login thing for, was it for the chat or something?
I don't think I've used Bcrypt before.
Somebody like used it for like a demo purpose, but didn't actually explain.
It is possible. So Bcrypt is, you might hear this term, especially a lot in encryption, called it's expensive, right? And what they mean by expensive is not that it's taking your credit card information or you have to feed it little coins into the CD slot for it to work. Expensive means it takes a lot of power, and power normally means CPU processing time. So the downside to using more sophisticated algorithms is that it's harder for the CPU to calculate that over and over and over again. But it is often considered worth it for the security level, right? So what we are going to do is we're going to make the switch to Bcrypt and take a pause from there. And then tomorrow, we're going to dive into how to make Bcrypt more viable. So every time we make an API call, we don't want to rehash it over and over and over again. So we're going to go through a way called cookies with session variables of how to store your authentication information in a secure way without having to run Bcrypt every single time. But let's just get Bcrypt working and then go from there. So what I'm going to do, my front end isn't going to change at all. Front end is still sending up the password. I'm just going to throw this in as a side note. It is possible to do encryption on the front end, so you aren't sending your password over the internet in plain text. If you try and do that now on any modern browser and you're not on localhost, Chrome will actually like throw all of these warnings and be like, whoa, this isn't secure. Developers screwed something up here. So ideally, all of the sites that you create are served over HTTPS. Whether it's through Let's Encrypt or you buy an SSL certificate, whatever it may be. One step you can do is do the encryption on the front end in your React code or wherever your front end is, and then send that hash up over the server. So instead of hashing it and encrypting it on the server side, you could do it on the front end. But for the purposes of just understanding encryption, we're doing it all on the back end so we can see where our salt gets added. Okay, with that little disclaimer, I am also going to const bcrypt equals require bcrypt. And now you might say to me, Max, if you're requiring it, don't you have to install it? And I would say, you're sure right, I do. So I'm going to npm install -- save bcrypt. And then I am going to start my server back up. And now that my server is running, when we create our account, instead of my generated password being MD5 and generating a salt, I don't need a salt anymore because Bcrypt is going to do that for me. And you know what? I don't need to save the salt in the database either, because Bcrypt is smart enough to have their hashing format include the salt right in the hash, which is pretty cool. So my generated password is now no longer going to be MD5 of what the user uploaded and the salt that I generated by hand. It is going to be bcrypt.hash. And it's going to say, well, what would you like to hash? rec.body.password. Okay. And now it takes a weird parameter. It takes the number of salt rounds. And basically what this is saying is, how many times do you want us to generate a salt and then rehash the password? And then take that hash, add another salt to it, and rehash that password, right? So basically you're saying, how secure do you want to make this? 10 is considered like the go-to, the default. Again, we could go very far down a rabbit hole of, well, is 1 secure enough? Is 10 secure enough? Is 100 secure enough? But for right now, we're just going to default it to 10. Okay, great. Now it's going to take the password and it's going to save it in. So before we go too far, let's make sure that's working. We are going to create ABC2. We're going to make our password ABC2, and we're going to confirm our password is ABC2. We're going to create the account, and we're going to get all kinds of errors in our server. And what's happening here is it's saying string violation, password cannot be an array or an object. Okay, so we did something wrong. So let's console log out our generated password. And we're going to go here. We're going to hit create account again. We're going to get another error. But look what consoled out. A promise. Bcrypt is going, I promise I'll generate the password. And then it's going into the database, and the database is going, promise what? I need this data. I want to throw this in. So the reason why we're seeing more and more of this is that this is actually good that the code is written this way, because what it does is, if it's running as a promise, it's saying that we can run this code asynchronously. So if we wanted to generate 1,000 different hashes right now, we wouldn't have to generate one hash, wait for it to finish, and move on to the next one. We could just tell Bcrypt, generate all 1000, and it's going to use all the different cores on the CPU and all the different RAM that is available to it to generate those 1000. So we don't need to do it one by one. We could generate thousands of passwords at a time, which is pretty cool, but it makes it a little bit harder to write the code to get just one working. So what we are going to do is we're going to say, hey, we need this hash before we can save it in the database. Just wait. I know you said you promised and that you'll return me the data eventually, but we'll wait and make sure you have that promise happen. But anytime we use a wait, we have to also make the parent function async. So we have to tell Node, hey, we're gonna do some asynchronous stuff in here, and when you hit an await, be prepared for it. Okay, so we're gonna save that. We'll leave our console log in to make sure this is working. Now, that's a major security issue. If you were to deploy this code, your database might be super secure and no one can get into the database and see those hashes. But every time someone creates an account, oh, we're going to throw that in the server logs. Well, more people may have access to your server logs than your secure database directly. So we want to make sure we don't leave that in. But for right now, we're testing it. We're on local. We're good. So I'm going to go in here. I'm going to, first of all, I want to make sure that I'm not filling my database up with other old user accounts. So I'm not. The only thing in here is ABC1. So I'm going to hit create account. I'm going to go back to my database. I'm going to refresh, and we see ABC2. Okay, and we see the password salt is still null. That's okay, because you notice our hash is much longer, but it has these weird $signs in it, which is okay. But we want to make sure if we're using salt, like I said, Bcrypt was using, if we create another user with this same password, the hashes should be different, right? So I'm going to create ABC3 with the same password. I'm going to hit create account. And when I refresh in the database, out comes something different. Now, what is the same is this format in the beginning. Now, what that's saying is that there are 10 salt rounds. So when you go and try and figure out if this hash matches something else, this is the way we generated the salt. So when Bcrypt goes to compare what the user uploaded to what's stored in the database, it knows what format it's stored in. It knows that there were 10 salt rounds used. And then the salt is stored in the rest of this string as well. Okay, so we are going to say ABC2. We're going to say our password is ABC2 because that's what we did when we created it. We're going to hit login and it says can't sign in. Okay, well, why is that? First of all, we see our hash coming out. We don't want that in the logs anymore. So we're going to remember to take out our console log. I feel like if we teach this class in the future, it's going to be more and more of this. It's going to be more and more of don't have a console log. Remember when Equifax, sorry, tangent. So in my login, I'm going to take out some of these old console logs because it was all working with MD5. But in here, we are going to say, hey, get the password from the database. The database is storing it with Bcrypt, so that's all hash. But we are going to totally cheat, and up here, before we compare it to the user database, we want Bcrypt to do all the heavy lifting for us. So we don't even have to do the compare. We're going to let Bcrypt handle that. So we are going to say const match equals bcrypt.compare. And what do we want to compare? We want to compare the rec.body.password, what the user typed in, to the user db.password. Okay, and we're going to console log out our match, and we won't even worry about this code right now. We just want it to, we just want to see what's happening with that match, right? We haven't used this compare before. We want to see what comes out. So we're going to go in, we're going to hit login. It says user signed in. That's just because I left this res.send here. But what happens here is a promise. I'm sick of these promises. So we're going to throw in await. We already have this as an async function. Why? Because our database uses asynchronous code as well. So in theory, we could execute thousands of database queries without having to wait for each one to finish before we start the next one. So we're going to await our Bcrypt compare. We're going to go back here. We're going to hit login. And what happens here? True. So that means it matched. Okay. And if I change my password and go, now it is false. So now Bcrypt is doing that compare for us. So all we have to do is say, well, if there is a match, say the user signed in, else say can't sign in. Great. Go back to our code. We're going to hit login. We get can't sign in. We get the error. But when we make our password match, user signed in. Okay. So we did a lot tonight. We built an entire authentication system from scratch. Yes.
Well, I have a question.
Okay. So we did really cool stuff here. Now the issue that we're going to run into is, well, we don't want to have to bcrypt.compare every single time someone goes to the server, but we want to make sure that every time someone loads something from the server, loads the users, loads inventory data, whenever they make an API request, we want to make sure they are signed in. But hashing their password time and time again seems like a lot. And it seems like a lot to be transmitting that password all the time as well. So starting tomorrow, we will go over sessions and cookies and how we can securely send that data back and forth. Then I will probably take a break, and anyone who wants to learn Firebase can continue, and anyone who doesn't want to learn Firebase can focus on the session code.
Right?
Tomorrow.
Oh.
And if I don't get to Firebase, you'll get it as a video.
Cool.
Okay? I'm going to save this code. I will push this to the sandbox repo. And then I will be around for the next at least 15 minutes to help people catch up to this state if they want, or if they want to go home, that's also fine. But by Sunday, I want everyone's code to be at least up to this point. And I will come hunt you down during capstone week if you don't send it to me. Okay?
I have a question.
Yeah.
Does Firebase cover like permissions? So like my project has like you sign in and then it gives you a personal dashboard experience. So like, are you gonna cover something like that? So like, how does it know what to show user after they log in?
Yeah. So there are 3 A's of logins and credentials. There is authentication, which is checking to see that you can get in, that you're authorized, right? There is authorization, which is saying, hey, only an admin should be able to do this. Are you an admin? So technically, if you use authorization without authentication, anyone can go, I'm an admin,
Yeah.
and they go, okay, that's fine. So authentication and authorization work together. One is saying, are you allowed to do this? The other one is saying, you are who you say you are, right? And we think of authentication as just username and password, but there are so many other ways to do authorization. Can anyone think of one?
Apple's two-way.
Like a birthday.
So two-factor authentication is 2 things. One, it is something you know, your password, and it's something you have, your phone. You can't get that code. The third way of authenticating is something you are. Anyone think of something you are?
Human?
What?
Human?
A what?
Human?
No, but like what is an authentication system that uses something you are?
Questions. Like
Something
questions.
that's something you know.
Alive.
Oh, so like your birthday?
Like biometrics?
Biometrics. Face ID is a perfect example, or touch ID, right? Fingerprint reader or a face scanner is something you are, right? You have a certain complexity, or your fingerprint has certain loops in it, or so those are the three ways you can authenticate. Yep. So something you are is just physical features or however it is read. You could do a blood test. You could use DNA, right? Whatever. Right. Something you have, right? Which is you use this every day to get into your house. When you go to your house, you put the key in the lock, and the lock goes, oh, that's something you have. You have the key. I can let you in, right? In computing, that would be a little two-factor token, or your phone that generates the code. And then something you know, whether it's security questions, whether it's your password, whatever it is. So two-factor authentication is just saying I use two of those three kinds of authentication. So the big wave right now that we're seeing is passwordless authentication, where you're just signing in with your computer. And it's something that you have, your physical computer, and then something you are. It does a quick face recognition or uses Touch ID. Now you just did two-factor authentication. It's not something you know, but the computer, the website goes, well, I recognize this computer, and I recognize that you were you, so great, go ahead in. So that is two-factor authentication, all under authentication. Authorization is, are you allowed to do this? Great, you're allowed into this software. That doesn't mean that you should necessarily be allowed to do whatever you're trying to do. Then the third A is auditing. Okay, great, you did whatever you did. Now we need to arrest someone for this Capital One hack. You were allowed to get into the logs. Okay, that's the problem. That's an authorization problem. And you were allowed to get into the system because you proved that you are who you say you were, and you used two-factor authentication, you signed in, all of that stuff. Now this massive leak happens. We need to figure out who leaked that. So auditing is a log trace of being able to say, okay, who did this? Who exported the data? Who put this data into the system? Who said that this data should be in the system? That is auditing. So you can audit without being authorized. How do you audit without being authorized? Well, someone logs into the system and it says you're not allowed into the system. Well, if someone's doing that 100,000 times in 60 seconds, I want to know who's trying to get into the system. So I should be logging their IP address, right? So you can audit completely without authorization or authentication. The 3 A's stand alone, but the 3 A's are the pillars of what makes a good security system. So I know that's kind of a little side tangent. In answer to your question, I would like to cover authorization. I don't know that I'll be able to get to it tomorrow, but I will either help you in a one-on-one, or if other people are dealing with authorizations in their capstones, I will also make a video and share that.
Yeah, that's cool. Like I think like in theory, like I know how like it should work.
Mm-hmm.
Like in terms of like, so if I have an account and I log into my app, and it's gonna then use my address information. That's it. Also, like I need to figure out how to store addresses, because that's also a security issue, right? So like I might need help with that in a separate session. But like I think I mentioned this on Monday, but then it needs to like use that address to then like show like information specific to that location.
Yep.
For the specific user. So it still needs to access like APIs and like the database.
Yep.
And then like mesh everything together after somebody's logged in. Like somebody shouldn't be able to access that before being logged in.
Yep. So we will cover the logged in part of that tomorrow. You shouldn't be able to access this unless you're logged in.
Right.
So we will cover that tomorrow, and then if there is enough time, I will cover authorization.
Okay.
I'm thinking it might be more valuable to cover Firebase than authorization.
No, and I can set up like a one-on-one for authorization, but I just like.
The other thing that I'm thinking about is like, do we just stick with this because what we just built from scratch is a secure system? And it's kind of cool to show that off, right? To an employer. It's like, look, not only can I just drop in a solution, I know how to make an auth system. I know the fundamentals of salting. I know all of that stuff. So we will just kind of play it all by ear tomorrow. Covering sessions is definitely a requirement. And then from there, we can figure out, do we want to go into authorization, or do we want to go into something like Firebase where we can just drop in that solution?
Thank you.
Yep. Any other questions for the class? Okay. Before I end the stream, I'm just going to show how I commit this. What I'm going to do before I push anything or commit anything, I'm going to pull, right? Because there are 19 different updates that all of you have made into that repo. So before I can push anything up, my computer actually won't let me send anything up new to the repository until I pull all of that new stuff down. So what I'm going to do is I'm going to pull that. I lied. This 19 is because I have 19 file changes. It isn't that there were 19 changes on the server. Okay. So first thing I'm going to do is I'm going to stage all of this. And what staging is you have all this code, all these file changes. What staging is going to do is tell Git what files I want to commit. So I'm going to hit the plus button, which stages all of them. Then I'm going to type in a message like first commit on auth project. And then I am going to hit this check button, which is actually making the commit happen. So I'm going to commit it, and that's all great, but that all happened on my local computer. None of that went up to GitHub. That's all sitting in my files. So I'm going to go here, and then I'm going to push. And pushing is going to take all those code changes that I made, that history of all those commits, and push them up to the server. How many people would like a Git video?
I wouldn't mind it. I feel pretty solid
Okay.
with it, but
Okay.
there's probably stuff I don't know.
Yeah.
Okay.
It's just playing it in air. And it's like, oh crap.
Yeah. And part of that has been that we're all in the same sandbox. So you could have actually not have done anything wrong, but because someone else changed their code and sent it up to the server, you can't now send your code up until you pull the changes that they made, and then you can push up yours. With that said, I will go over a basic Git flow and how to avoid those problems. Any other questions? Okay.